Okay, good morning and welcome to this fourth iteration of Cyber Jagrookta Diwas. It is an initiative being taken up by IITISM Dhanbad in order to increase the awareness about cyber physical systems and any security issues associated with them. With us, we have Venkata Sai Charan Putrevu. He doesn't probably require much of an introduction. He's been with us before, but just to give you a brief revision of the introduction that I gave last time. Charan is a PhD scholar at the Department of Computer Science and Engineering, IIT Kanpur. He's the holder of the prestigious PMRF scholarship, and he has worked extensively in the field of cybersecurity, not just as a research scholar, but he has also worked in the industry. So he does have a lot of go-to knowledge in some ways. In the previous iteration of his talk, he talked about different types of cyber attacks. We had a very nice communication about what type of things people usually try to do with cyber physical systems. And this talk is just going to be a continuation of his first talk. So without wasting too much of time, I'm just going to hand over the podium to Charan. Charan, over to you.
Thank you. Thank you for the nice introduction, sir. So this is the high-level agenda of today's talk. So I will try to, scratch some basics because some of the participants are new. So in the previous talk, we saw about what is APTs and what is advanced persistent threats and what is some state-of-the-art attribution techniques and what is some naming conventions related to the APTs. So now we will discuss the extension part. So we will discuss some state-of-the-art APT detection mechanisms in this talk, and we will try to discuss what is the current trend of anti-VM and anti-debugging trends in this APT detection as well, and some of the state-of-the-art industrial attribution frameworks like FireEye atomic framework. So how they will do this kind of thing, and we will towards the end we will discuss about some gaps in this area and what are all our contributions to this APT detection for the last 2 years, and we will have a discussion. So let's get started. So as we all know, APT stands for Advanced Persistent Threats. So these are state-sponsored hacking called malware campaigns, which stays inside the targeted network for a long time undetected. So they will try to, exfiltrate the sensitive data from, various countries and banks and, ministries of various governments, etc. So broadly speaking, these are all the 7 life cycle phases of APT. So it's like from they will do the initial compromise. From there they will try to establish the foothold by replicating itself into several other missions by exploiting some 0 days or widely known CVEs, and then they do the series of privilege escalations in that particular network to get into a strong position in that particular corporate organization or network. Then they will do the internal reconnaissance to gather or to identify the sensitive data where they might found the sensitive data, and then they move laterally from one LAN to another LAN, one VLAN to another VLAN for searching for the data, and they maintain the persistence. So on the reboots also, on they will hide the traces in the network, and they will maintain the persistence for a long period of time, and they will collect all the data, and they use clever techniques of exfiltration. That means they will wrap the data in such a way that it will not be traced at the network firewall level, and then they will try to establish a communication to the C2C server, that is called as control and command server, and they will push the payloads to external control and command server by using some clever data exfiltration techniques. So this is the broad life cycle of APT and what we have discussed in the previous part 1 presentation. And coming to the APT attribution process, so what is APT attribution? So in order, if some APT attack happens, so how we can able to tell that so this attack was happened from this country and this attack was originated from this country, and what is the reason behind this particular attack? So this was so APT attribution process will give answers to these kind of questions. So as we discussed in the previous class, so previous lecture, so what they will do is they will collect the indicators of compromise from the victim networks, and they will cluster those indicators of compromise as the intrusion sets. And after collecting, they will do the series of machine learning techniques, and they will observe the trends for a particular period of time, and they will perform the analysis, and they will finally come up with a what is the motive behind this particular attack and where it got originated from. So this is called as this is the overall process of APT attribution. So there are many security firms usually do this APT attribution process, FireEye and Kaspersky and CrowdStrike. So we have discussed about the naming conventions also. So most famous naming convention was this CrowdStrike one. So they will attribute the the attackers by based on some different animal names, which will reflect the country name. So bear stands for Russian, and Chinese stands panda stands for Chinese one, and kitten stands for Iranian one, and tiger stands for Indian one. So as of now, we have 130 APT groups which are publicly disclosed by various security firms. So all the things that we have discussed in the previous seminar and up to this part, so it needs more of a manual analysis. So it takes a lot of time, and there is no automation kind of thing. So in order to overcome this drawback, the security firm FireEye came up with this atomic framework to attribute to automate the process of this APT attribution. So what they will do is like in this particular atomic framework, they will they have observed a trend for last 5 years. There is a abnormal surge in the unclustered APT groups, or unclustered or unattributed APT groups. So either they have to attribute these unclustered groups to some new APT, or they have to merge it with some other old APT groups based on the different things, indicators of compromise. So because of this pile up, they came up with this solution. So what they will do is like they will initially gather this unclustered group indicators of compromise, and they are using a unique algorithm called true frequency or inverse document frequency. So it is called as TF-IDF algorithms. It is a famous document clustering approach that was widely popular across various security firms as well. So they have used this thing. So basic idea of this TF-IDF algorithm is that it will find out unique terms from a individual document, and if the terms appears across all the documents, the priority will be decreased. So because of this, you will get to know what are all the unique terms which are related to a particular malware family. And after gathering, after assigning this code to this particular unclustered groups, they will convert the entire group into a vector form, and then they have calculated the cosine similarity between these unclustered group vectors to actually attribute. So if the theta of this thing is very less, that means these two vectors tend to be closed, and that means they are clustered or merged together as a single group. So they will, if some new group comes, they will find out the cosine similarity with the existing groups, and they will try to check whether it will be merged or whether it will be attributed as a new APT group. So this is how the FireEye has automated the entire framework for APT attribution. So now there is no manual analysis process, and there is no sitting together for months for identifying the APT groups. So this is the high level idea of this FireEye atomic framework. Now we have almost covered several APT attribution frameworks like 4C model, diamond model, and mythic framework, and now we have seen the new automated framework from FireEye called atomic framework. Now from now onwards, I will jump into the APT detection mechanisms. So broadly speaking, APT detection is kind of a difficult task in the real time. So although there are several techniques which are targeted towards a particular life cycle phase of APT, so there are very few and less frameworks or models are available which will address which will be addressing all the life cycle phases of APT. So I'm trying to cover two such frameworks in this presentation. So one is called as MLAPT and second one is called Terminaptor. So we will take a look into these two things. So this one was the first one. In this first work, I will be discussing some detection mechanisms by using machine learning and machine learning correlation analysis. So in this particular work, the researchers has proposed, three individual modules. So first module is threat detection module, and second module is alert correlation module, and the third module is attack prediction module. So what is I will explain the architecture in detail in the next slide. So I will just touch what are all the sub modules present in this threat detection module, so that you will get a better idea while understanding the architecture. So what they have done is they have they have gathered, or they have collected the network traffic in a promiscuous mode, and all that network traffic is sent to this series of sub modules that they have designed. So a disguised file detection module will try to detect the try to identify the content of the file is exe or not, even though the extension is not exe. And malicious file hash detection module, so whatever the downloaded files in this particular network, it will try to generate the SHA-256 and MD5 hashes of this file detection module, and it will verify that with the blacklisted via virus total file hashes, and generate the alerts. And third one is malicious subdomain detection module. So usually these APT groups will try to communicate to external control and command server through some malicious domain generation algorithm. So the domain names which will be looking like a normal domains, but they are malicious. So it will try to establish a secure connection to that domains, and then it will exfiltrate the data. So the malicious file domain detection module will try to identify that kind of blacklisted domain names. And malicious IP address detection module will try to address the malicious IPs that every host in the machine, every host system in this particular network is trying to connect to. And malicious SSL certificate detection module. So for every connection established, it will try to get the certificate, and it will try to match those certificates with the blacklisted blacklisted list of these SSL certificates. And domain flux detection module. So domain flux means the attacker will constantly change the IP address and the domain name. So if there is any DNS query failures are happening in the network, it will this module will try to identify is there any DNS resolution failures are there in this particular network or not. And the scan detection module will try to identify the failed connection establishment requests in the network. And TOR connection detection module will try to identify if there is any TOR active connection is there in the network or not. So we will see about these two modules in the architecture phase. So now you will get a better picture. So all the network traffic will be given to these 8 detection modules that they have designed. And all these 8 detection modules generate a series of alerts, I can say. So all these alerts will be given to this alert correlation module. There are basically 3 submodules in this alert correlation module. So first one was alert filter, alert clustering, and correlation indexing. So alert filter means it will try to remove or clean the redundant alerts, and it will basically remove the scrap. And then alert clustering. So in order to identify the APT attack, we need to understand that this series of attacks need to be happened in a particular time bound. So what they will do is like this particular module will take the data from this detection module, and it will cluster the alerts based on a particular time interval. And then this correlation indexing module will give the score that whether it's a full APT scenario or sub APT scenario. So what is full APT scenario or sub APT scenario, I will clearly explain in this this slide. So the basic idea is very simple. So if the malware is trying to do all the life cycle phases, touch all the life cycle phases of APT, then it is called as a full full APT, what we can say, full APT alert. Or otherwise, if it is a if it is just trying to touch some points like point of entry, and if sometimes it might just do this control and command server communication, so that kind of things are called as a sub APT scenarios. So for full APT scenarios, for A, B, like point of entry, control and command server communication, then asset discovery and data acceleration, all these four things need to be happen, then it is called as a full APT scenario. Or if some cases, let's say if C2C communication happens and then it will try to exfiltrate the data, then that is called as a sub APT scenario. So this is the difference between full APT scenario and sub APT scenario. So it will identify based on the after the clustering, the correlation indexing will identify which are full APT scenarios and which are sub APT scenarios. And the third one was the prediction module. So here the task of the prediction module is to identify the sub APT scenarios, and then they will try to find out the probability. So they have taken the previous 6 months of data, and then they have trained their models to identify the malicious and the benign APT scenarios. So these supervised models, what they will do is like they will identify the sub APT scenarios, and they will calculate what kind of sub APT scenarios might turn out into a full APT scenarios. So based on that thing, this prediction module will raise an alert to the network security team, and based on that, the network security team will take the necessary action to bring down that particular LAN or bring down the particular victim machine, to minimize the damage on a in a corporate network. So this is the high level idea of this MLAPT architecture. So the main key thing is, apart from all other APT detection techniques, so this will try to cover each and every life cycle phase of APT. So for point of entry, these three modules will take care of this point of entry, the life cycle phase, and malicious IP detection module and malicious SSL certificate detection module and domain flex detection will try to identify the control and command server communication, and scanning detection module and other detection module will try to address the lateral movement, and scanning detection will find the asset discovery, and Tor connection will try to identify the data exfiltration phase. So that's why this is considered as a state of the art technique in APT detection mechanisms. So coming to the pros and cons of this APT detection, MLAPT detection technique. So as I said earlier, so this was the one of the technique which will identify the APT attacks from on a whole. It will cover all the life cycle phases of APT, and the segregation of modules are so clear that they will pinpointed each and every module for targeting for a particular phase, and that's why the prediction accuracy for this model is comparatively when compared to the previous works. And coming to the drawbacks, or other side of the coin, so there are some other latest techniques called lolbin, so which is called as living offline binaries. So recently this kind of attacks became very popular across various corporate networks. So lolbin means the attacker will not try to deploy the payload. So it will the attacker will try to get the entry into the victim networks and victim machines, then by abusing or by using some legitimate Windows applications, so he will craft the payload inside the victim. Then he will use that payload to compromise the other machines or escalate the series of privileges. So these are called as living offline binaries. So all the things will be done in the victim machine only by using the legitimate applications. So that's why it is very difficult to identify these kind of lolbin attacks. So this disguised file detection modules, and there are several modules which can't able to identify this kind of logging attacks. And the another drawback, or drawback we can identify in this particular thing is like the prediction module will take the previous 6 months of data to predict the upcoming latest attack. So I don't think this is a feasible for large scale network. And this is like a toy example, we can say. So this will work for the toy examples. In the real time scenarios, it is very difficult to identify the novel attacks by taking the previous 6 months of data. And there are some deprecated modules like tor detection modules nowadays. No attacker is using tor detection module. They are using some custom encoding or encryption mechanisms to push the payloads securely to the external control and command servers. So for another thing is like these are all simulated in a university environment. So they have gathered some 100 full APT scenarios and 50 sub level 3 and sub level 2, 50 sub level 2, and they have taken random events. So this can be considered although the intuition is very good, this can be considered as a toy examples in the real time scenario. So um, that is about this MLAPT architecture and MLAPT detection mechanisms for APT detection. And the second thing I would like to discuss about this Terminaptor. So basic idea of this Terminaptor model is that APTs are represented as a succession of elementary attacks. So we can say that this after this attack will happen. And so there is a series of actions happens in this APT life cycle phases. So here the idea of this particular research is very simple. So the detecting APT according to this research paper is that highlighting the links between the elementary attacks. So here the others suggested to track these elementary attacks by using the events. So if we can able to track the events in a clear way, then we can able to identify the links between these events in a particular time bound. Then we can able to track the APT attacks. So this is the high level idea of this Terminaptor. So for performance experiment, they have install they have assumed that there is a agent uh, agent installed in each and every mission of the corporate network, and they will collect the continuous security logs from these all the missions of the network. And then they are going to monitor, and they're going to analyze the events that are happening in this thing. So this is the idea. And how it will actually real time how it will actually work, you will get to understand by using this sample event codes that I have collected from from my master's thesis. So I have analyzed the APT piece of malware sample. So from this thing you will see the series of events that are happening. So these are Windows event codes, and this is meaning of this particular event code. So this series will repeat over the period of time. So you can see that now 4648 means there is a login session happened. Somebody is trying to log on to the victim machine, and 4624 means the successful login session is created. And after successful login session 4672 happens. That means a series of sensitive privileges got escalated in this victim machine. So like security privilege, ownership privilege, load driver privilege, and backup privilege, restore privilege, debug privilege, and set an environment privilege, and impersonate privilege. So all these privileges got escalated after the login. And then after this series of privileges, the firewall went down 7036. And after this firewall went down, so there is a name resolution happened. So that means it is trying to connect to external control and command server for the name resolution, DNS name resolution. Then it will try to stop the Windows updates and Windows there are several host intrusion detection systems and experience setups or experience Windows experience things also it will try to stop. So this is a series of events that we have identified. So the clear thing that we need to understand is, like, if you are a Windows user and if you try to, you know, stop the firewall manually, the 7036 event happens. So we can't consider that one as a, you know, malicious activity. You need to identify a series of malicious activities over a period of time, and then only we can, you know, say that this is a APT attack. So in order to identify this series of event codes, they have given a tag to each newly detected attack, and from this tag they will track what kind of other things are also happening. So by using this Markov chains, they will assign a weight that, you know, after this one, this attack happens, then it might be a APT attack. So they will track this, you know, paths to identify the APT attack. So this is the high level idea of this, you know, terminal-after APT detection mechanisms. So coming to the pros and cons of this terminal-after, the intuition is very good about this, identifying the basic elementary level events to attack, you know, detect the APT patterns. And another good thing is that processing is done at the some other party or some third party server or third party machine. So the attacker who is sitting in this particular victim machine can't able to identify what is happening. So whether is there any security alt or security thing is going or not, they don't know. That is a good thing about this terminal-after. And coming to the cons of this particular terminal-after, so as we discussed earlier, same lol-bin attacks can be used by the attackers to bypass this kind of security mechanisms. And you know, it is very cumbersome to, you know, track the events from each and every machine of the large scale corporate networks. So ideally it is impossible. This might work good in paper and theoretical or some demo lab examples, but in the real time, collecting logs from, you know, thousands of machines in a corporate network is a huge task, and we need to have a very huge big data processing techniques to identify this kind of event tracking mechanisms. Ideally, even though there is a big data processing techniques are available, it is very difficult to, you know, give a real-time alerts by using this kind of attacks. And I can say that, you know, theoretically this is okay, but in real time scenarios there are several gray areas in this particular paper where research work, where, you know, it can be, you know, patched in a way so that it can detect the APTs in a better way. So this is about, you know, terminal-after APT detection mechanism. And now we will take a look at anti-debugging techniques and anti-VM techniques of this APT malware. So what is this anti-VM technique? So if a particular piece of malware is executing in your network, it will check if it is executing in a sandbox environment, or if it is executing in a controlled environment or not. So if that is executing in a controlled environment, it will not show its original behavior. So that is called as the anti-VM technique. And coming to the anti-debugging technique, so it is little bit different from anti-VM technique. So the basic idea of anti-debugging technique is that if somebody is trying to, you know, reverse engineer that payload by using some tools like IDA Pro or not, so it will never show the original path. So it will try to take them to, you know, irreversible loop, and it will make the things harder for the, you know, security analysts to find out what is actually happening in this malware. So this is called as anti-debugging technique. So it is preventing the, you know, security experts to debug and dig down and debug what is actually happening in this particular piece of payload. So these are called as anti-VM techniques and anti-debugging techniques. So this is a survey paper on how this APT malware is using this anti-debugging techniques and anti-VM techniques. So they have collected the malware samples of, you know, 16,000 generic malware samples and 1,000 targeted malware samples for this experiment, and they have done a series of analysis. Their research mainly targeted to address these three questions. So does the targeted malware, I mean APT malware, is using more debugging techniques or anti-VM techniques. So what is the trade-off of these things with the APT detection rate? So these for answering these questions, they have done an analysis by using Sperman's correlation index. So it is basically a statistical model which will try to find out the correlation between two individual variables. So we can say that so for the first result, so anti-debugging techniques versus anti-debugging techniques in APT malware, it is having the positive correlation index. That means if the anti-debugging techniques versus time, that means over the period of time, the use of anti-debugging techniques got increased in a large way in this APT malware. You can clearly see that use of, so this black one was APT thing, so APT malware. So if you can see from 2009, 10, 11, 12, it got increased to a good in a proper way. And coming to the anti-VM techniques, if they have calculated the Sperman correlation between anti-VM and the time, so if it is having the negative correlation index, that means over a period of time this anti-VM techniques got reduced in usage, or by especially crafting this APT payloads. So from this thing, use of anti-VM techniques, you can really see that there is a sudden drop in after 2012, especially while for the APT scenarios. And they have observed very good thing, very good observations from this analysis as well. So there is a negative correlation between detection rate and the anti-debugging techniques. That means if the attackers got to know that if they are using more anti-debugging techniques, the detection rate is less. So that's why you can correlate this one with the first hypothesis or the result that they have made. So the detection rate goes down when the anti-debugging techniques got increased. So that's why they are using more anti-debugging techniques over a period of time. And just opposite to that anti-debugging techniques, over a period of time, the detection, if you can able to see this thing, there is a positive correlation index between anti-VM techniques and the detection rate. That means if they are using more anti-VM techniques, they are definitely caught by some antivirus or some network intrusion detection systems and or some firewall. So that's why they are reducing these anti-VM techniques over a period of time, and then they are using more number of anti-debugging techniques, which will make the security community too hard to identify what kind of thing that particular payload is doing in the real time. So reverse engineering will be very tough with this anti-debugging techniques. So this is the high level overview of their research work. So coming to the gap analysis, as we discussed in the previous lecture also, so there is no single solution to this whole APT detection problem. So we need to identify, like some other ransomware or some other botnet, we have a single solution to identify the and take a necessary action. But in this case of APT scenarios, there is no single solution. We have to work on individual life cycle phases of this APT to give a good comprehensive solution for this thing. And another problem that we are observing here from IIT Kanpur is that this whole APT life cycle is so agile and reconfigurable. That means they constantly change these patterns or TTPs in each life cycle phase of APT. So sometimes they will come up with some XSS attack, and some next time they will come up with some new XSRF attack for exploiting the same vulnerability. So that's why it becomes very difficult and very agile to so this APT lifecycle is very agile, so that detection becomes very difficult in the real time. Another thing is that the targeted malware is recently, we can say that it was mutated into some kind of smart malware. So this smart malware is very intelligent enough. It has intelligence embedded while in the design itself. So it will only target the specific person or individual, and other time it will try to interact with several legitimate applications in the Windows environment to stay low inside the network. And it is very intelligent. Whenever it identify a particular victim, then only it will try to do some malicious activity. So that kind of attackers has embedded the machine learning and intelligence into the malware payload, so that it will be very difficult for addressing or identifying this kind of payloads. And recently we have seen a exponential growth in terms of new methods of payload delivery. So attackers are using fileless malware. So the whole the malware, for the entire life cycle, the malware will stay only in the RAM, so it will never touch the hard disk throughout its execution. That is called as fileless malware. And it is very difficult to deal with this kind of targeted fileless malware. And it will whenever, even though if we reboot the system, it will hide the traces in the boot sector, and it will again come up when we reboot the system. So post pandemic, it got increased by 500 times. So this targeted fileless malware was quite popular in nowadays. And on a whole, we can say that defenders are on a behind a back seat when compared to the APT detection mechanisms and the attribution mechanisms. Recent attacks on SolarWinds and Microsoft, and Red Echo attacks on Indian power sector are the clear evidences that to identify the defender's position or attacker's position in this particular game. So from these challenges, we can say that we need to have a comprehensive solution targeting each and every life cycle phases of APT. And one has to tighten the screws of their corporate networks or academia also. So they need to tighten the screws of their old school defense techniques. So with this kind of novel APT targeted attacks, so it is very easy to bypass traditional old school defense systems, like intrusion detection systems or firewalls. So we need to be very cautious about this kind of attacks. And after identifying all these things, I will try to just give a glimpse about what we are actually doing in IITK. So my work is mainly on this data. I actually try to target different life cycle phases of APT. So my first work is on identifying the malicious domains which are actually working in the data exfiltration phases. So these malware payloads will try to communicate to control and command server by using a simple domain name like this activityprocess.com or more likes today.com or manygoodnews.com. So these are all called as word based domain generation algorithms. So these are generated by running some algorithm. So this algorithm will fetch two keywords from the dictionary, and then it will append these two keywords, and they will make that website, and that website will be registered by the attackers from the outside. And whenever this particular algorithm runs inside the victim network, it will generate a series of domain names, and this malware payload will try to try each and every domain name for the name resolution. And whenever something hits, then it will try to connect to that malicious domain or malicious server by getting the IP from this DNS resolution. So these are all called as word-based domain generation algorithms. So I have worked on this word-based domain generation algorithms, and we have mainly concentrated on this Marchnu, Gozi, and Supperbox families. So we did so this is the broad idea, and these are all the list of features we have covered. We have taken around some 15 network based and lexical based features from various repositories, and we have collected some malicious domains from some other standard repositories, and we have collected genuine domains from some Alexa, and then we have applied some various ensembles models to identify these malicious domains, and we got some good results as well. So after this thing, we try to actually identify the correlation between these features. So that means how one feature is correlating to all other features. So based on that thing, and we have done the feature importance also, like which feature is contributing more to the model. Based on that thing, then we have reduced the features manually to from 15 to 8. Then and we got a decent accuracy as well to identify these malicious domains. And then we applied both linear and non-linear dimensionality reduction techniques to understand the underlying geometry of this our data. And then based on that thing, we reduced the feature sets. And to evaluate our model, we have used synthetic tabular GAN. So it is a generative adversarial networks to generate the synthetic data. So we have generated that malicious synthetic data and pushed to verify the accuracy of our model. So to actually check the robustness of our model. So this is the high level work which we have done in the last year. And now we are extensively working on designing a target specific malware. So that means let's say, even though if entire computer science department got infected with this APT thing, so it will not work for everyone. So it will only start executing whenever it sees a particular result. Let's say, for example, Professor Saurabh Srivastava. So it will whenever it sees or it listens to the voice of the Professor Saurabh Srivastava, then it will start executing the payload on that particular machine and try to exfiltrate some sensitive data. So we have executed various payloads by using this mechanism, and this is under review currently. So we have done some 6 experiments by using these smart malware design principles. So this is the high level work which we have done here. And for any queries or any doubts, or I have given all the literature in this particular paper, and feel free to drop me a mail, or we can connect on LinkedIn as well for any kind of help from my end. So that's all from my end. So now I'm ready to take the questions. Thank you.
Thank you, Charan. That was a very good and to be honest, a very intense talk. Any questions from the audience? Okay, so I do have some questions from my end as well. So one thing that I'm just trying to understand the whole concept of lol bins. So essentially, they are basically a kind of self-sufficient program that somehow ends up on a particular machine, and then it starts kind of a chain reaction. But all this happens in an offline fashion, right? It doesn't require communicating with the command center for whatever it is trying to do. If is this what a lol bin is, if I can understand?
So yes, sir. So the name itself is living offline binary. So usually the attacker, once the attacker will try to compromise the network or victim machine, and then once it got compromised, initially the payload will be very light. Initial malicious payload will be very light, and then they will try to establish a connection to the C2C server for downloading the more payloads. So most of the malwares will get caught at this particular level. So in order to avoid that, what they are doing is that they are writing a small scripts kind of thing, which will come along with the initial compromise payload, which will try to abuse the legitimate DLLs or legitimate binaries of Windows machine, like crypto binaries are there. So for executing the ransomware, it will try to make use of the existing binaries in that particular machine, and they will try to use that binaries, and then they will craft the payload to execute and encrypt the machines, kind of thing. So it's, you can say that it's a self-sufficient and so individual kind of thing. We can say that individual, and you can't actually track, because if you can track, they are trying to interact with legitimate services of Windows. So no malware, no intrusion detection, host intrusion detection system will stop, because it is actually communicating to legitimate Windows service. And then by using that Windows legitimate services, they are crafting a payload which will do the malicious activity. So that's what the lolbin is.
Okay, so basically you are just creating a monster there first and then
Yes.
using that monster to, okay.
Yes.
The second thing, and this is about the work that you have already done, and that is this whole concept of trying to figure out if a particular domain name is malicious or not, right? And I can understand the way it is done is that you use two dictionary words, two random dictionary words, you merge them together, and then these attackers will actually get it registered at their name. And from what I understand, the workflow is something like this, that the malware will also try to use the same algorithm and try to generate these names, and then it will keep on making DNS probes, and the moment it gets a hit, it can then communicate, right?
Yes.
So when you talked about these ML based APT detection mechanisms, some 7 8 different modules that these guys have built, have they actually looked into this part as well? Have they tried to create some kind of a module that can, because to me it looks a very interesting problem, because in order to hit the correct the currently available malicious domain, you'll have to make a number of DNS probes.
Yes.
And this could probably generate a kind of pattern that may be studied at the network level, and maybe a detection system can be added to that in order to detect this pattern, because there's a good chance that all these malware will probably generate the same kind of pattern. They'll probably go through the same set of false positives first before
Yes.
hitting the correct domain. So have they done anything like this, and are you planning to do something like this?
Sir, in the MLAPT, they have a specific module for domain flex or domain generation, domain detection kind of thing. So it is there. This problem exists. This problem is existing for a long time, sir. So initially, it was like a character-based domain generation algorithm. So they are using some cryptographic LFSR kind of thing to generate some random numbers, and then they are appending some .com or .in, something like that. So it's like ones, zeros, mixes of characters and numbers. So the ML models became very intelligent enough to try, by looking at them, we can easily say that these are malicious domains. So that's why attackers has changed their strategy, that they are pulling two dictionaries words from the some random places, and they are attaching. So these two has to be uh, you know run in a parallel thing. So attacker and the detection,
It's a
so
cat
they
and mouse game.
cat and mouse game. So they are constantly coming up with new kind of algorithms which will look like a. So basically, I have told about this Matsno, Gozi, and Sapobox, right? So these are families, latest families of domain generation algorithms. There are several other families as well. So currently, there are some other researchers are also looking into this problem, but the main problem is with the detection accuracy. So if you apply some neural networks on this thing, it will definitely fail, because the whole legitimate Alexa domain names will exactly look like the normal ones. So we can't actually segregate that. So that's why we have taken some. That's why we have not taken only the lexical things. We have taken lexical things, network based features, and who is data information. So for every domain, we used to have a date of creation and date of updation, and TTL time will be there. So it will be very less for these kind of malicious domains, so that they will constantly change the IP address which are attached to this particular domain. So based on these features, we actually built a better algorithm, better model kind of thing, to detect them in an efficient way. But there are some researchers are extensively working on this problem, I can say.
Yeah, I mean, I can understand that. As I said, it's a cat and mouse game. So the moment you come up with a solution that fails their work, they'll actually come up with something else, because
Yes.
they have the what can I say, luxury of the attacker, the person who initiates the event,
Yes.
right?
So after this algorithm, recently I got to know that so they stopped working on this DJ algorithms. Attackers stopped working on. So they are trying to now look into the Twitter feed. So if that particular tweet was happened, then only they will execute the payload. Something like that.
Yeah, so that's so yeah, I mean the way they'll actually start these events, the triggers could be from anywhere, right? It's
Anyway,
not just
yes.
necessary to be. Yeah, that does make sense. It's a very as I said, it's a difficult field to work in. Right. Okay, any other audience member who has any questions or queries? Okay, so Charan, let me again thank you for being with us for a second time. And it was really nice listening to all the things that are going on in the field of APT, and how you guys are also trying to contribute towards making our lives better. So thanks a lot, Charan. And on behalf of IIT ISM, I would like to thank you for being with us. And thank you everyone else who joined us for this session. This will be it from our side. Thank you. Bye. Have a good day.
Bye, sir. Thank you.